Hi guys, welcome to the class of communication systems and technology. And today we are going to discuss about the noise. So if we are talking about the channel, and channel in basically we have different components of communication model. So in channel there's distortion and then noise. So what's noise? It's basically undesirable signals added between the transmitter and the receiver. When we transmit our signal from one point to another point, then in between the transmitter and receiver there is the addition of an signal. That signal is undesirable. So we can say that that signal, undesirable signal, is known as what? Noise. So this one is our transmitted signal, and this one is our received signal. So there is addition of little bit an undesirable signal, that is known as what? Noise. So we have different types of noise. So first of all, thermal noise. So due to random motion of electrons in a wire, means there is the noise which is produced due to the random motion of electrons in a wire, or you can say that in the medium. So the noise due to the motion of electrons is known as what? Thermal noise. And then we have crosstalk noise. Crosstalk noise signals from one line picked up by another. Let's open this example. If there is one signal is transmitted over wire 1 and another signal is transmitted over wire 2. If wire 1 is picked a little bit signal from the wire 2, then that is also considered as a noise. So that noise, that type of noise, is known as what? Crosstalk noise. And then we have impulse. It's basically irregular pulses or spikes, like example lightning. So the impulses or this type of noise are very short in duration and high amplitude. Okay, so these pulses are high in amplitude, but they are short in duration. So we can say that the short duration pulses or the high impulses with high amplitude, or the spikes with the high amplitude, is known as what? Impulse noise. So now there is an important signal to noise ratio. So we can calculate the signal to noise ratio. It is important for the communication, that SNR. SNR means signal to noise ratio. So power of signal divided by power of noise. Power of signal means the signal which we want to transmit. So the power of that signal divided by the power of noise. So through this formula we can calculate signal to noise ratio. So take an example of signal to noise ratio, and the power of signal is 10 milliwatts. Okay, and the power of the noise is 1 microwatt. What are the values of SNR and SNR dB? Okay, so first of all, we have 10 milliwatts the power of the signal, and then 1 microwatt the power of what? Noise. So now we have two different powers, okay, and they have two different units. So first of all, necessary for calculation that we must have units in one single unit. So let's suppose if there is 10 milliwatts, so another one is 1 microwatt. So either we convert it, they both powers in microwatts or both in milliwatt. So okay, let's start with the solution. The values of SNR and SNR have been calculated as SNR is equal to, let's suppose I convert this 10 milliwatts into microwatt. Yes, this 10 milliwatts, I converted this 10 milliwatts into what? Microwatts. So if I convert this microwatts, so it will be equal to 10,000 microwatts. And then this one is 1 microwatt, so it's 1 micro, sorry, it's by mistake, it's not milli, it's micro. Okay, so this one is 1 microwatt. So microwatt cancel with each other. Now remaining is 10,000 because ratio it have no any unit. So SNR dB is equal to 10 log 10 of power p, means so we can calculate, put here SNR 10,000. So 10 log 10,000 is equal to 10 log of 10 power 4, and that is equal to 40. So we can say that the value of SNR is 10,000 and the value of SNR dB is 40. So in this process, we can calculate signal to noise ratio. So there's channel, and channel we have signal attenuation, and then we have signal distortions, and then there's in noise, there's impulse or crosstalk noise. So thank you guys. We will meet in the next video session with